All right, let's do this again. So 7.4, permutations and combinations from the top one more time. So in this section, we're going to talk about how you compute factorials. I kind of already gave you a little foreshadowing on how to do that in the last video. We're going to talk about applying and calculating permutations, as well as doing the same for combinations. And then finally, talking about solving applications involving permutations and combinations. So the two important concepts here that we're going to introduce is permutations and combinations. And for both of these, we're going to need to use the symbol factorial. Factorial doesn't mean a number with excitement, even though you are probably excited about doing math. So here's the deal. Factorial is just basically repeated multiplication from that number down to 1. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. If, say, you had 8 factorial, it'd be 8 times 6, 7 times 6 times 5 times 4 times 3 times 2 times 1, all the way down. That's basically factorial. Another way that we can think of factorial is n factorial is the same thing as n times n minus 1 factorial. So that'd be like rewriting this up here as 5 times 4 factorial, because then you do every number after 4 multiplied through. That's nice when we want to maybe simplify problems by hand. 0 factorial is 1 by definition, okay? By the way, most calculators will have the factorial button. I'll show you that here in a little bit when I do the permutations and combinations on your calculator as well. One thing to note is that n factorial goes really large really quickly on your calculator, and you'll end up with overflow errors if you do, like, say, 20 factorial. You'll notice that your calculator is very upset with you. So just be mindful of that if you have issues like that. Okay, so the simplest protein molecule in biology is called vasopressin, and it's composed of 8 amino acids that are chemically bounded together in a particular order. The order in which these amino acids occurs is of vital importance to the proper function of vasopressin. If these 8 amino acids were placed in a hat and drawn out randomly, one by one, how many different arrangements of these 8 amino acids are possible? Some of you guys already know that's 8 times 7 times 6 times 4, 5 times 4 times 3 times 2 times 1. Yes, that's correct, right? We'd make 8 slots, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's 8 factorial, basically. And so there's 40,320 different ways that you can get that. Pretty crazy if you think about it. Now, here are 2 problems that illustrate basically combinations and permutations. And I think this is a great example, and I'd write this down in your notes because this will help you keep it straight. So consider the set P, E, and N, right? We just did sets in a previous section. So how many 2-letter words can be made that it doesn't matter if they make any sense? Nonsense words, we'll say, like P and E, P and N, E and N, E and P, N and E, N and P, right? So basically you'd see that I think there are 6 different possible ways we could have it, right? P and E, P and N, E and N, E and P, N and P, N and E, right? By the way, P and E and E and P are actually technically different for this context because these are different words, okay? Now, what if instead, though, I said there were 3 male names, Paul, Ed, and Nick, and I wanted to know how many 2-man crews could be selected from the set? Well, in that case, you'd look back up at this and say P and E is the same thing as E and P, because Paul and Ed is the same thing as Ed and Paul, right? Unless you're thinking one is better than the other, but they're still the same 2-man group. So this is basically combinations and permutations. The first is an example of permutations, and where order matters, okay? Order matters. And combinations is basically where order does not matter, okay? So in this case, think permutations, order matters. Combinations, order does not matter. In other words, the way that you arrange those 2-man groups, order doesn't matter. Permutations is how many different 2-letter words you can make, which seems silly, but you know, that's the example I want to use. I think this is a really good illustration of the two. So in permutations, the order is important, okay? And so one of the things now is we want to talk about the notation for how we write out permutations. So sometimes you might see P, parentheses, N, and R. N is the number of objects, and R is the ways or how many you want to take at a time. More commonly, though, it's always written as NPR, which is not National Public Radio, but NPR. So I'll show you on your calculator in a second where you can find that. We'll show you the formula, though. So in this case, the formula, and I'm going to make my screen up here a little bit bigger so you guys can see this, because I'm going to write it down, and so you guys should write it down in your notes too. So we'll have NPR is equal to n factorial over n minus r factorial. Yep, there we go. Better check to make sure that's actually in the screen. So in this case, if we do 3 permute 2, right? That's going to be 3 factorial over 3 minus 2 factorial. Well, that's 3 factorial. 3 minus 2 is what? 1, that's right, 1 factorial. So that's going to be 3 times 2 times 1 over 1 factorial, which is just 1. So we get 6. Some of you guys are like, yeah, I could have just saw 3 times 2 times 1 is 6, divided by 1, 6. Awesome. Now, let's suppose you want to double check on your calculator. So in this case, we'll go to math, and you'll see PROB, and that stands for probability. And you'll see NPR, NCR, and factorial. Those are going to become very common for us to use. So let's throw that NPR in there, and let's make sure. So let's put in 3 permute 2, and what do we get? We get 6 as our answer. Sorry, I zoomed in a little too much, but there you go. Okay, we're going to do a couple more examples here, and we'll show how to do it. So let's find 5 of 3, all right? So let's do it by hand first to make sure we understand what we're doing. So 5 permute 3 is going to be, and I'm going to try to keep this as steady as possible. So 5 factorial over 5 minus 3 factorial, which is really 5 factorial over 2 factorial. Well, if we want to write that out, that's the same thing as 5 times 4 times 3 times 2 factorial over 2 factorial, right? Well, these 2 factorials will go away, and I'm left with 5 times 4 times 3, which is really just, yeah, that's right, 60. Oops, move that over so you guys can see that. Yeah. Some of you guys might just say that's 120 divided by 2, which is 60 as well. Yep. And now again, throw it in your calculator just to double check. Again, one of those things that's super nice about working with your calculator is you can always hit second enter when you have something like this in there. And you can put in that number of 5, and we're going to permute, whoops, 5 permute 3, and we get 60, which is the same answer I said, right? Boom. All right, let's make sure we know how to get there. Math, prob, whoops, I'm too fast, prob, and then you'll see NPR there, okay? And that's what you'll do. If you have an older calculator, sometimes it'll just put answer in and then NPR, so you might have to work with that a little bit. Let's go through the solution. Yep, 60 is what we said, right? So one way you could think of this as an application is how many ways can you seat 3 people on a, seat 5 people on a bench that seats 3 people in a park. Seems kind of silly, but it's crazy to think that there's 60 different ways you could do that. And this is where basically order matters, like to how people sit down on there. And again, here's another way you can think about it if you want to think of it with intuition. So, all right, let's do 5 permute 5. The reason why this is important is just kind of illustrate what this means, okay? So if we do this by hand, we'll have 5 permute 5. So 5 factorial over 5 minus 5 factorial. Well, that's 5 factorial over 0 factorial. Again, remember 0 factorial by definition equals 1. That's a definitional thing. So we basically have 5 factorial, which is 120. Let's just verify that again. So if you're in your calculator, you put that factorial in there. And in this case, it's going to put my last answer in there. So what you can do is choose second, can't see my fingers, second insert, which is the delete key. But I'm just going to put 5 in there and hit enter. Yeah, gives me 120. Great. Again, feel free to pause the video if you're rewind. Just trying to keep it quick, fast moving for you guys. A bookshelf has space for exactly 5 books. How many different ways can 5 books be arranged on this bookshelf? It's crazy to think 120 different ways to me. So, all right. So we feel pretty good about that one. That was that example. So in the second problem, though, we had combinations. So combinations was talking about the 2-man crews, okay? And basically, in this case, order does not matter, okay? So this is going to be NCR, and this is basically order does not matter, okay? I'm sorry, those are really close, but I'm just trying to make it there. So let's do an example here. You'll see that basically it's the permutation divided by the R, but let's just write it out so we have the formula. So in this case, n factorial over n minus r factorial times r factorial. I know they have r factorial times n minus r factorial. I just usually write it this way, just out of habit. So again, order does not matter here. So let's find C, 8 of 5. Okay, so here's what we're going to do. We're going to do, again, 8, choose 5. So we write that out. It'll be 8 factorial over 8 minus 5 factorial times 5 factorial. So a shorter way, stabilize that out. And I gotta move this up. It's just in my way a little bit. All right, so I have basically 8 times 7 times 6 times 5 factorial, right? I'm writing this out just kind of so you can see this again if you want to break this down and you're doing this by hand. 8 minus 5 is 3 factorial times 5 factorial. Well, 5 factorials will go away, right? Because you can factor them out. And 3 factorial is really just 6. So the 6's will go away and I'm left with 8 times 7, which is 56. Let's just verify that that's correct with our calculator, okay? So let's pull out our calculator. We'll go to math, probability. We're doing combinations this time. And we have 8 and we're choosing 5. And we get 56, which is the same answer. Awesome, right? And again, you can watch this as well. So now if you choose 8 in this case, so this is where order doesn't matter. So no matter what, I think you're gonna see that this is just 1. Well, let's do this. So 8 choose 8 is gonna yield basically 8 factorial over 8 minus 8 factorial times 8 factorial, which is just 8 factorial over 0 factorial times 8 factorial. Well, 8 factorial over 8 factorial is just, don't say 0, it's 1, right? And 0 factorial is 1, so this is just going to be 1. So, and you can put that in your calculator too if you want to double check that. All right, so let's do a couple of examples so that way you guys feel understanding about this. So how many ways can you choose 5 out of 10 friends you invite to a party? So let me ask you this, does order matter? In this case, order does not matter, right? Like Tom, John, Sally, Jackie, and I already said Tom, Ben, all right? Is the same as if I said Jackie, John, Ben, Tom, right? That's the same, okay? So basically in this case, order doesn't matter. So this is gonna be a combinations, right? So in this case, we would do 10, choose 5, right? And so if we do that, I think you're gonna find we'll get 252. And you can double check with your calculator if you want. Again, know how to do this by hand so you can show your work on an exam. All right. How many ways can you arrange 10 books on a bookshelf that has space for only 5 books? Well, let's say this, does order matter? I think order might matter depending on how we want to arrange it on the bookshelf. So if order does matter, then we're going to use permutations. So in this case, I'll move this out of the way. It's going to be permutations, and there's going to be 30,240 ways we can arrange it, which is pretty crazy to think. You're only going to put 5 books on the shelf, and you have 10 books. So it's really important to understand whether arrangement matters or doesn't matter, okay? All right, let's do this lottery problem. So a certain state lottery consists of selecting a set of 6 numbers randomly from a set of 49. To win the lottery, you must select the correct set of 6 numbers. Notice it didn't say the correct order, right? You just have to select the correct set of 6 numbers, okay? It's a lot of S's for me for some reason. How many possible lottery tickets are there, right? So in this case, we know that there are 49, and are we gonna permute or choose? So I think you're gonna see that the order does not matter, right? In a lottery ticket, you can have the numbers backwards, but as long as you have the right numbers, you win. So this is gonna be a combination. So 49 choose 6, right? So I think this is gonna give us a big number. So let's just, the other thing, remember when you have your calculator, you can always do these quick tricks like second enter. And let's see if I can get this to focus. There we go. And I'm gonna put that 49 in there, delete that 8, and put my 6 in there. And I get basically 13,983,816. Let's see if that's what we got. Yeah, we could do it that way. I'm not gonna do it by hand because otherwise it's a little bit longer. And I think that's it for all of this chapter. And these are the problems I have. Again, you can find this under files. So let me know if you have any questions. Be happy to help you out.